Hello students, so continuing our lectures on interpolation. So in our previous lecture we had discussed about, that is lecture number 236. We started about discussing spline interpolation and discussed about piecewise uh, linear interpolation. And where we are matching the discrete points through matching the different slopes for x and y, x and say f. Now to match the curves as well, we like to match the curves to look the interpolation as smooth. Then we require this cubic interpolation, so we will take this up in this lecture. So in cubic spline fit, we use the cubic polynomial we call this one as f1x, fix to represent the function in each interval. So interval is represented by say xi and say xi plus 1. So we need to fit this cubic polynomial inside this interval. Now if there are n points, that means we have n values of xi and fxi, where I starts from 1 to n, and so the number of intervals being n minus 1 is the number of intervals. So there are n minus 1 cubic splines. So these n minus 1 cubic splines which needs to be fit. So the cubic polynomial chosen is such that each interior point is called a notch and the following conditions are satisfied. So these are the notch, these interior points. We have the notch where we are getting the values. So one is for fxi, this is fxi plus 1, so on and so forth. And the following conditions needs to be satisfied for cubic polynomial fit. The conditions are as follows. First, fi xi plus 1 should be equal to fi plus 1 xi plus 1. The polynomial should be the same for the two different points. Secondly, fi dash xi plus 1 should be equal to fi plus 1 dash xi plus 1, the differentiation. So this is valid for I is equal to 1 to n minus 2, and the same is also applied here. I is equal to 1 to n minus 2, and the third condition, so this is the first condition, this is the second condition, and the third condition that needs to be satisfied is the double differentiation of xi plus 1 should be equal to double differentiation xi plus 1 xi plus 1, and this one is also valid for I is equal to 1 to n minus 2. So what are these three conditions physically? So these the first condition mean the joining of the points, The second condition mean stands for the slope, so that we have the same slope. Because see, if there are 2 points like this one say x1 and f1, and this one is say x2 f2, then there are different ways by which we can join them. Like we can join them either this way, and this way. So the first one represents joining, while the second one is they should be joined linearly. That means they should have the same slope. So the second condition takes care of the slope, the first condition takes care of the joining, and the last condition takes care of the curvature. So if there are 3 points, x1, y1, so in this case also, there are points, say this is say x1, f1, 1 point here, this is x2, f2, another point, and this is x3, f3, so there are 3 points. So it's not only that they need to be joined only through slope, but the curvature needs to be maintained. So that curvature is taken care by the second differentiation and this condition. So this is how this cubic spline line condition works. So the equations for the polynomial in each interval are derived by first observing that the second derivative of fix has straight lines in each interval. And the equations for the second derivatives are as follows. It should be fi x is equal to ai xi minus xi plus 1 divided by xi. So this is not x, this is x. This is x minus xi minus 1 and xi minus xi plus 1 plus ai plus 1 divided by x minus xi divided by xi plus 1 minus xi. So and the values run from I is equal to 1, 2 and minus 1, where ai is equal to f double x xi and ai plus 1 is equal to double x xi plus 1. So if we integrate this equation twice, we'll come up with the following. So if we integrate twice, this one is twice, so we get the following relation. Okay. Now here we get for relation, we get fix is equal to f double xi fx I minus xi plus 1 whole cube divided by 6 xi minus xi plus 1 plus f double x xi plus 1 into x minus xi whole cube into 6 xi plus 1 6i plus a x minus xi plus b x minus xi plus 1. Okay. Where this a and b are the two constants of integration to determinant. A and b are determined by substituting the values fix at x is equal to xi and x is equal to xi plus 1, which are tabulated points. So after doing this following, we get the following relation. We get if ix is equal to f double x xi into x minus xi plus 1 whole cube into 6 xi minus xi plus 1 plus f double x xi plus 1 into x minus xi whole cube divided by 6 xi plus 1 minus xi plus fxi plus 1 divided by xi plus 1 minus xi minus f double x xi plus 1 divided by 6 into xi plus 1 minus xi into x minus xi plus fxi divided by xi minus xi plus 1 minus f double xi by 6 into xi minus xi plus 1 into x minus xi plus 1. So this is actually the cubic form of the equation which is used. So let's take an example to find the interpolation, or to use interpolation in cubic spline. So we have the following equation. We have been given the following values of fx, xi and fi, and they are 1, 2, 3, 4 and 5. We have 1, 4, we have 30, we have 15, we have 32, we have 18, and we have 25. So, and we have to find the value of fx at x is equal to 3.5. So what we will do, we'll use the equation. We'll use this equation, xi plus 1 minus xi into f double differentiation fxi plus 2 into f xi plus 2 minus xi into f double differentiation xi plus 1 plus xi plus 2 minus xi plus 1 into f double differentiation xi plus 2. So using this relationship here, x is equal to 3.5 means we are talking about this. So this happens to be I, this happens to be I plus 1, and this happens to be I plus 2. So using this relationship we get the following. So we get f double differentiation x 1 plus, so this is I is equal to 1, I is equal to 2. So this is 2 minus 1 into fx1 plus this is 2 into, the interval again is 1 here, so interval is 2 here, that means 3 minus 1. So 2 into 2 becomes 4 to f double differentiation x2 plus 6 f double differentiation x3, and so again if we simplify this, so it turns out to be equal to 6 divided by xi plus 2 minus xi plus 1 into f x I plus 2 minus f x I plus 1 minus 6 x I plus 1 minus x I into f x I plus 1 minus f x I. So this is actually the final equation. So putting the previous values obtained here, these values, we get this one as equal to 6 divided by 32 minus 15. 32 because this is 32, this is 15, minus 6 into 15 minus 30, because this is 15 and 30, and these are all either 1 or 2 values, so that makes it as equal to 192. So this is the first value. The second for the second case, we have f double dash x2 plus 4 double dash x3. Now we have taken, now first we started with this value, considering this is I1 fx1. Now we are going to start with second, and third we will start with this. So we are basically matching 3 points. So this is x1 y1, so we have matched these first 2 points. Now we will match the second 1, 2 and 3 second points, these 2, and then we will match the fourth point. So 1, 2, 3, 4. So this process is over. Now we're moving on to this process, matching the second and the third point. So for that case, this equation comes into the picture. Fx3 plus f x4, and so by using this equation again, this is equal to 6 into 18 minus 32, considering the points that we obtained here. Now 18 and 32, and 32 and 15 will come into the picture. 18 into 32 minus 6 into 32 minus 15. So we get the value as minus 186. Now we move on to the next step, that is joining the third and the fourth point. So in that case, we get the following equation: f double differentiation x3 plus 4 into double differentiation x4 plus f double differentiation x5. So we get 6 into 25 minus 18 minus 6 into 18 minus 32. So we get the values 126 here. So if we now consider the first, so we have 5 points: 1, 2, 3, 4 and 5. So if we consider the there are no, so this is where the curve ends. Okay, the first point and the last point, the fifth point, I is equal to 1 and I is equal to 5. So if we assume the curvature ends here, we need to write this as that the double differentiation at fx1 double differentiation fx1 is equal to 0 and fx5 is equal to 0. So considering these two conditions, we get 4 x2 plus f x3 as equal to 192 as obtained previously, we get the next equation as f double differentiation x 2 plus 4 double differentiation x3 plus f double differentiation x4 as equal to minus 186. Lastly, the third case, f double differentiation x3 plus 4 into double differentiation x4 is equal to 126. So what we have done here, simply we have removed, so here you can say this is for x5. We have removed this, we have not considered this, because if x5 is equal to 0, we have not considered this equation if x1 is equal to 0. So no, this is if x4. Not considered this one. This we have not considered, and that is nothing to cancel here, because so there's nothing to consider because x2, x3, and x4, three of them are non-zero values. So we have removed f double differentiation x5 this condition, and we have removed double differentiation x1. So we come with these three equations: equation number 1, equation number 2, equation number 3, and by solving these three equations we obtain the following values. We obtain f double differentiation x2 is equal to 67, f double differentiation x3 as equal to minus 75.9, and f double differentiation x4 as equal to 50.5. So now put the now we will get the equations. That means we'll get the cubic splines. For f1x we'll get 67, that is fx2 into x minus 1, fxi minus fxi plus 1 whole cube divided by 6 plus 15 minus 67 by 6 into x minus 1 plus minus 30 into x minus 2. This is for f1x. For f2x we will get 67 into x minus 3 whole cube divided by minus 6 plus minus 75.9, that is f double differentiation x3 into x minus 2 whole cube divided by 6 plus 35 plus 75.9 divided by 6 into x minus 2, the second polynomial, and the third one is there's one more term here, plus minus 15 plus 67 by 6 into x minus 3. And the next one is the third polynomial f3x. It is equal to minus 75.9 into x minus 4 whole cube divided by minus 6 plus 50.5 into x minus 3 whole cube divided by 6 plus 18 minus 50.5 divided by 6 into x minus 5. So x minus 3 plus minus 32 minus 75.9 divided by 6 into x minus 4. Lastly, we get f4x is equal to 50.5. These are all obtained by integrating it twice. 50.5 divided by minus 6 into x minus 5 whole cube plus 25 into x minus 4 plus minus 18 plus 50.5 by 6 into x minus 5. So this is how you will get the final solution. So here a checkpoint, a check of the following relationship can be obtained. We can say that f1 x1. Let's write the equation, write the values once again. So we first started with, we have been given the following values, that is xi and fi. We've given 1, 2, 3, 4 and 5, and corresponding values are 30, 15, 32, 18 and 25. And we have been asked to find the value of fx at x is equal to 3.5. This is the initial problem. So till now we have the following values. We have f1 x1 as equal to 30, f2 x2 as equal to 30 also, f2 is equal to f1 x1, since the points have to be matched, is equal to 30, and we have f2 x3 is equal to f3 x3 as equal to 32. So this is the point, this is the point, and this is the point. We have f3 x4 as equal to 18, which is equal to f4 x4, and we have f4 x5 is equal to again 25. So this is the first condition. The second, this is joining of the points. So out of the three conditions mentioned above, this is the first condition. The second condition is the first differentiation. So f1 dash x2 is equal to f2 dash x2, f2 dash x3 is equal to f3 dash x3, and f3 dash x4 is equal to f3 f4 dash x4. So this is matching of the slopes. This is matching of the point, this is matching of the slopes, and the next step is matching of the curvature. So now f1 double differentiation x1 is equal to f4 double differentiation x5, and this is equal to 0, the first case. So ultimately we have fx is equal to 3.5 is equal to f3 3.5, and from the values obtained, this is equal to 75.9. That is 75.9 is the value obtained as f double differentiation x3 by 6 into 3.5 minus 4 whole cube plus 50.5 divided by 6 into 3.5 minus 3 whole cube plus 18 minus 50.5 by 6 into 3.5 minus 3 plus minus 32 minus 75.9 divided by 6 into 3.5 minus 4, and the value comes up to equal to 26.6. So let us understand what are these values are. This is nothing but 75.9 is nothing but f double differentiation x3, and 50.5 is f double differentiation x4, and this is x minus xi plus 1, sorry, x minus, okay, f xi plus 1, this is fx minus xi plus 2, and this is fxi I plus 2. 18 is of course the value obtained x4. This is 32 is fx3. This is again xi plus x5 minus x1. 5 minus 1 comes as 6. These are all 5 minus 1 values. So putting this value, this is the final answer that we get, 26.6. For the fx is equal to 3.5.